Battery production has always been a bit of a tedious process. Tech entrepreneur Elon Musk is on a mission to overhaul this process and to maximize efficiency. In pursuit of this mission, he has invested years of time and money into the largest building in the world, the Tesla Gigafactory. This enormous factory is expertly designed to manufacture Tesla products, including batteries, at a rapid pace using sophisticated automation and innovative solutions. Let's take a look inside and find out what makes this factory so efficient at producing batteries and more. What is Tesla's Gigafactory? Technology has evolved at rapid speed in recent history. Computer chips and processing power have boomed, but batteries have not quite scaled in growth the way other tech has. The process and efficiency has remained somewhat stagnant. Elon Musk is seeking to change that to help pull more and more consumers over to his electric vehicles. Rather than developing their own batteries, Tesla partnered with technology company veteran Panasonic, a company that's been building tech and batteries for decades. Musk convinced Panasonic to move their production line into the Tesla Gigafactory, which allows them to cut down on the delays of shipping the batteries. This is one of many steps in streamlining the process and cutting down on time to produce batteries. The Tesla Gigafactory in Sparks, Nevada, is the largest single footprint for a building in the world. It was carefully designed to be fully optimized for production with extreme emphasis on automation. The factory was built on the true north so that the many robots operating inside could easily be programmed using GPS. Elon Musk has voiced in the past that he has more engineers working on advancing the design of the production line than he actually has on advancing the products. But how exactly are those battery cells actually manufactured anyway? How are batteries made? Battery cells are functionally useless when they first roll off the production line. They need to be aged. Cell aging is when a protective layer known as the SEI, or solid electrolyte interface, forms around the electrodes. This process generally takes 10 to 12 days, which is far too slow for the ambitious goals of Musk. Tesla and Panasonic have developed a means of aging the cells in place as part of a whole battery at the Gigafactory, thereby ramping up efficiency and speeding up the process overall. Musk has publicly voiced issues with his partnership with Panasonic and is actively pursuing the ability to produce batteries independent of the tech giant. This public pressure has bred innovation on the part of Panasonic. The company has moved on to producing larger, more efficient batteries known as the 2170, in place of the previous standard 18650. These newer style batteries are instrumental in Tesla's pursuit of high-efficiency, maximum output electric vehicles. Musk has stated a goal of a highly affordable $25,000 Tesla vehicle, and one of the largest obstacles in the way of that price target is the battery cost. But what other changes are on the horizon for battery tech to continue the innovation boom? What is the future of battery technology? Elon Musk has complained about the reliance on costly and environmentally unsustainable materials such as lithium and cobalt. He imagines a future where these batteries no longer rely on these rare earth materials, and it may be coming very soon. CNBC recently reported on the future of batteries, and it is as simple as a single letter change from lithium-ion to lithium-iron. Current batteries are what we call lithium-ion batteries, and they are top of the line. The next generation is being called lithium iron phosphate batteries. Switching from lithium-ion to lithium iron phosphate has the potential to cut down on costs of battery manufacturing, extend the range of an electric vehicle charge to 400 miles, and extend the lifetime of the vehicle to 1 million miles. These are certainly ambitious goals, but it could be the next big game changer to the electric vehicle industry. The 100,000 miles warranty changed the vehicle industry and gave consumers more confidence in their car purchases. Guaranteeing 1 million miles out of an electric vehicle would be a giant leap forward in consumer confidence. Lithium-ion batteries have a long shelf life, but not quite long enough to hold value for the resale of an electric vehicle. This means there isn't much of a market for pre-owned electric vehicles, especially not compared to the market of pre-owned gas-powered vehicles. But by switching to the new lithium iron phosphate batteries and extending the battery life to 1 million miles, a whole new market of pre-owned EVs becomes a reality, thus lowering the entire cost of owning an electric vehicle. But what exactly is the difference between lithium-ion batteries and lithium iron phosphate batteries? Well, lithium iron phosphate batteries have existed for a while and have primarily been used as electricity storage cells. They haven't yet been properly implemented as a power source, particularly not for electric vehicles, but have been proven extremely effective at storing large sums of power. The key difference is that lithium iron phosphate batteries don't rely on cobalt. Battery manufacturers have been trying to eliminate cobalt from the equation for decades. Cobalt is a rare and expensive earth material that has kept the cost of production of batteries high. According to James Frith, head of energy storage at Bloomberg New Energy Finance in London, in order for electric vehicles to be considered real cost competitors to internal combustion vehicles, they need to lower the cost of batteries below $100 per kilowatt hour. Current battery production sits right around $147 per kilowatt hour, which is down considerably from $1,000 in 2010 and $381 in 2015. By reducing the industry reliance on cobalt, they may in fact achieve this threshold. Battery Day 2020. In September 2020, Elon Musk hosted an event dubbed Battery Day, where he made several exciting announcements regarding the future of Tesla's battery plans. There, he announced that Tesla would start production on its own new battery dubbed the tabless battery. This tabless battery removes a tab that connects the battery to what it is powering and apparently can increase the power by 6 times. This announcement falls squarely in line with Musk's desire to cut the reliance on Panasonic and move into a fully in-house operation. Musk also announced a new North American cathode plant that will make the process 76% cheaper and produce zero wastewater. Texas and Oklahoma were among the potential sites for this cathode plant. This event was also where Musk reiterated his commitment to eliminating cobalt entirely from his company's batteries. The Tesla batteries use very little cobalt as it is, but Musk doubled down on the goal to completely eliminate the costly and often unethically sourced material entirely from the line. All of this battery innovation is what will eventually lead to the widely available and highly affordable $25,000 full electric Tesla for consumers. As it stands right now, Teslas are priced considerably above the average new internal combustion-based vehicle. But bringing the technology to a price point that lines up with the latest mid-model gas-powered vehicles, well, that quickly removes one of the biggest obstacles to a fully electric future. What are the keys to rapid battery manufacturing? So, how exactly does all of this work together to produce efficient batteries at rapid speed? Well, Musk identified the major issues in battery production and systematically worked to eliminate as many as possible. He housed as much of the operation as possible under the same enormous roof and automated the system to a degree that he himself has said may have been excessive. Musk is always looking at the horizon for the next big thing and setting his goals extremely high. By publicly announcing the many plans for the future of battery tech and Tesla cars, he's driving the entire industry forward as competitors race to keep up and partners strive to maintain their relationships. It would seem that Musk's emphasis on improving the process has in fact led to improving the product overall. We'll just have to wait and see exactly how the big battery day promises pan out. And maybe one day soon, we'll all be able to stroll over to the dealership and get our hands on an affordable, fully electric, 1 million miles guaranteed shiny new car.